Alrighty, we are going to have a lesson for balancing redox reactions using the half reaction method. This is for AP Skyview Chem, and just a little extra examples. I'm going to do two redox reactions that are not in an acidic solution, and then I'm going to do one that is, so you can stop or fast forward this video to wherever you need it. Remember, the goal that we're going for is to balance the electrons gained and lost so they are equal within the half reactions, then to add them up to write the final complete balanced reaction. If we are in an acidic solution, our last or third example of this video, we are going to need to look at hydrogen ions to balance the charges if they are not charged. So bring negative charges up, all right, or positive charges up, or however we're going to do it, and then waters to balance the oxygens. All right. The first one, we are not going to need to do this. All right. We don't need to do this because we are not in an acidic solution. So you're more than welcome to look at module 1.2. Okay. And within 1.2, you're going to see the balancing redox reactions lesson. Oh, I'm sorry, module 1.3. My bad, I was doing year one. Balance redox reaction, so 1.3, and then open that, and you're going to see a PowerPoint, and some of the steps that I'm talking about readily in here are listed in that PowerPoint. So if you want a written version of the steps, they are there for you that we've done in class already. Okie doke. So the very first thing that we're looking at here is we are going to be looking at writing the half reaction. So what is oxidized and what is reduced? I like to start with the reduced half reaction because I think it's easier to recognize. In order to do this, you have to assign oxidation states to every element here. So this is 2 negative because oxygen is 2 negative, and this is a neutral compound, so this must be 2 positive. Free uncombined elements are always 0, so these are my assigning oxidation states rules we did earlier in class. Copper's by itself. There's no charge on it, so it must be solid copper. It's free uncombined. This is a gas. This actually is a solid. Okay. And then we have liquid water. All right, so this is 2 negative, and therefore this is 1 plus. There are our oxidation states. Now we look at what's happening. Oxygen is not oxidized or reduced. Copper is reduced from 2 to 0. So my copper half reaction would be CuO, and then we'll do the arrow, gives you Cu0. So this is a 2 plus. You might need to write that up there for yourself. And whenever you have a reduction half reaction, you are going to be gaining electrons. And in this case, I have to gain 2 electrons to get to 0. Okay? Now, before you move on from here, you look at what is actually reduced, just the copper, and you ask yourself, is it balanced? If it was not, you would need a coefficient and change the electrons being gained. But in this case, copper is 1 coming in and 1 coming out, so only 2 electrons are being exchanged here. Okay, oxidized. Well, what's being oxidized is hydrogen. So we're going to take our H2, and it's going to make water. And we are going to lose, well, how many are we losing? This was 0, and this was 1 positive. Okay, so we are only going to lose 1 electron. This 2 is balanced, so we are only losing 1 electron. We don't need to multiply anything by 2 here. This is just the half reaction. So hydrogens coming and going are 2 to 2 naturally in their formulas. So I look at the charges, and I've lost 1 electron. Okay. That is the first portion of writing half reactions. You must do that portion, and then you do the part that everybody wants to zoom into, but you have to take your time leading into it. So once you've gotten to that point, now we can compare half reactions. Our goal is to balance the electrons gained and lost. So you have to see if that's happening. I have 2 gained electrons and 1 lost electron. You've got to balance that. And you do that by multiplying 2 throughout this structure. Now, I have 2 electrons lost as well. That is the redox balancing that's different than the traditional balancing. At this point, I'm now going to add this whole thing back up and see if I have a balanced version of this net. So I'm going to bring my arrow down, and I'm going to take all of my reactants and put them together from the half reactions. Copper was a solid substance, plus a couple waters, plus 2 electrons. And what's really nice about this is that the 2 electrons coming and going are equal, and this is liquid water. It's room temperature. So really, I know that I have achieved a balanced reaction. And a lot of you are like, well, I could have done that without doing the electrons. But this is an easy problem. So what you normally would do in the olden days of year 1, of just using a 2 and a 2 to balance everything, is not going to work for the electrons here. But we can double check everything. Copper, copper, oxygen, oxygen, 4 hydrogens, 4 hydrogens. All right, there we go. All right. So we needed 2's in front of those because the electrons needed balanced. All right, I'm going to do a second video for the next 2. So take a moment, look at this one, and then on Plan Book, look at the second video that will do another neutral redox and an acidic redox.